Hello, class. I'm going to go over EOC review number 6, geometry. I'll go ahead. Let's share my screen. Okay. And I am going to go through notes that you already have. You don't have to rewrite notes, but I do need for you to focus and pay attention to what I'm saying so that you can get it. Please go back and look at your notes. This is page 16 in your notes in quarter number 2, page 16. And it was writing equations for parallel lines. If you need to take a picture of this, you can. But please make sure you go over it. Okay, so if you're writing equations for parallel lines are lines that are in the same plane, but they never cross each other, okay? They have the same slope. Remember, parallel lines, linear equations, they're written in y equals mx plus b because they form straight lines, and they have the same slopes, okay? So they have the same slopes. So the steps for writing equations for parallel lines. First thing is you need to find the slope of the line that's given. So this is what they're going to give you. They're going to say, write an equation that's parallel to another equation of some sort. And it goes through a point. So they're going to give you an equation and they're going to give you a point. So the equation that they give you, find the slope of it. The slope here is the number that's attached to x because it's written in slope-intercept form. So that's m. So your slope is m. So now all you got to do is find b. Okay, find the y-intercept. So you have your slope. So you know your slope is going to be 2. And you're going to take the point that's given and plug it into y equals mx plus b. So now what you have, you substitute this 1 in. 2 is your slope. 6 is your x coordinate plus b. Simplify right here. This gives you 12. Bring down to 1. So now you solve for b. To get b by itself, get rid of the positive 12. So you're going to subtract 12 on both sides. 1 minus 12 gives you a negative 11. So your b is a negative 11, and your slope, which was given, is 2. So this line is parallel to the line that was given, and it goes through this point. And that's how you do that. So you're going to have problems where you're going to have to write an equation that's parallel to another equation that's given and goes through a point. Okay, so parallel lines have same slopes. Okay, so let's look at perpendicular lines then. All right, perpendicular lines are still straight lines, so you write them in slope-intercept form, y equals mx plus b. They're linear, they're straight lines. But the only thing that's different, perpendicular lines, they cross each other. They're lines that cross each other to form 4 right angles. And these are examples of what perpendicular lines look like. Their slopes are not the same. Their slopes are opposite reciprocals. So if one of the slopes is 2, then the other slope is not just a negative, but it's also the reciprocal. So the reciprocal of 2 over 1 is 1 over 2. So not only do you have to change the sign, but you have to flip it. The numerator becomes the denominator and the denominator becomes the numerator. So if this is the slope of one of the equations, negative 4 over 3, then the other slope is going to be a positive because this is a negative. So this one's going to be a positive, and you flip it. You see how the numerator and the denominator flips? These are slopes of perpendicular lines. Parallel lines have same slope. Perpendicular lines have opposite reciprocal slopes. Okay, so look. So you're going to do given the same type of thing again. Look at this. Write an equation that is perpendicular to this linear equation right here, to this line. And it goes through this point. So they give you an equation and they give you a point. So you're doing the same thing again. So identify what the slope is. The slope is a negative 3. I'm going to write it as a fraction, negative 3 over 1. Because the slope of the other line has to be opposite reciprocal if it's perpendicular. So if this is negative, this is going to be positive. So this is 3 over 1, this has got to be 1 over 3. So the slope is a positive 1 over 3, which is opposite reciprocal of the slope that's given. So now substitute this slope into the equation along with the x and y point that they gave you. So your y is 8, so put that there in the place of y. Your slope is 1/3, and your x is 6, but write it as a fraction since you're dealing with fractions here. So simplify this fraction by multiplying straight across. This is 1 times 6, which is 6. This is 3 times 1, which is 3. So you have 6 over 3 plus b. Bring down the plus b. Bring down the 8. Simplify 6 over 3 to 2. To get b by itself, subtract both sides by 2, and that gives you b is 6. So your slope is 1/3, and your y-intercept is 6. So it's y is equal to 1/3 x plus 6. If you need to take a picture of that, please do. Okay, pause for the calls or watch it again. All right, the other thing in this unit, geometry section, is Pythagorean theorem and distance on a coordinate plane. So Pythagorean theorem is where you use the this formula can only be used with a right triangle. So you cannot use Pythagorean theorem with just any old triangle. It has to be a right triangle. So remember, a right triangle has 190-degree angle, just like you see in the examples here. The side lengths, your A and your B, are the sides that form the right angle. So this is my A and B, okay? The side opposite of the right angle is your hypotenuse, or your C, okay? The formula for Pythagorean theorem is a squared plus b squared equals c squared, where your A and your B are your legs, okay? Those are your legs. Your hypotenuse, again, is the slanted side, and it's the longest side out of the 3 sides. So C is always going to be the longest side, and it's the side opposite of the right angle. It's always opposite of the right angle. Then your A and B, doesn't matter which one you label A and which one you label B, they're both legs. They form the right angle, okay? All right, so let's see what that looks like. Look at this. Okay, so your legs are 3 and 4. Okay, and you're trying to find your hypotenuse. In order to find your hypotenuse, substitute the information that you know. Even if you're solving for A, substitute all the information you know and isolate the variable. Do not forget, the opposite of squaring a number is square root. The opposite of cubing a number is cube root, and so on and so forth. So here, when you substitute 3 and 4 into the equation, you get 3 squared, which is 9. 3 times 3 is 9. 4 squared, 4 times 4 is 16. Add it, and that gives you 25. Bring down the c squared. Okay, so now look, to get rid of the to get rid of the squared, the opposite of squaring a number is square root. So you find the square root on both sides, and that gives you 5. Okay, that gives you 5. All right, don't forget that. Okay. Finding the midpoint and end point. Okay, do not forget that a line segment is a part of a line. It has 2 endpoints. This is a line segment here. It has 2 endpoints. A line, by definition, just continues without end. So we're talking about a line segment when we're talking about finding the midpoint. So you got 2 endpoints, and the midpoint is going to be the point that's in the middle between the 2 endpoints. Okay, so your midpoint is the point that's in the middle. It's an ordered pair. This is your midpoint formula. You got to know this by heart. You're going to take your x's, add them together, and divide by 2, like finding the average of the x's. So take your x coordinates of your endpoints, add them together, and divide by 2. Take your y coordinates of the endpoints and add them together and divide by 2. And that's going to give you your point that's going to be in the middle, your x and y value for the point that's going to be in the middle. It says find the midpoint between these 2 points. Label it. First point, x1, y1. Second point, x2, y2. Use the midpoint formula. Take the x's. You see these x's right here? Add them together and divide by 2. Take the y's. Add them together, then divide by 2. So when I add this together, look at what I get. I get 1 over 2. When I add this together, I get 1, and then I bring down the over 2. I can leave it as a fraction, or I can write it as a decimal. Okay, leave it as a fraction or write it as a decimal. Choose the best answer choice. Okay. Now, what if the endpoint is what's missing? Okay, look at this. Suppose they give you an endpoint and a midpoint, and they want you to find the other endpoint. So this is what you're going to use the same, really use the same formula. Okay, so look at what I'm doing here. Okay, So to find the x coordinate, I know what I had to do was to add the x's together and divide by 2. Okay. To find the y coordinate, add the y's together and divide by 2. So all I'm going to do is substitute the information that I know. It says find the endpoint. Well, one of the endpoints is 3, 5, and the midpoint is -2 and 7. So I'm working backwards really. So this was my answer before. So I'm going to take this first, this -2, which was my answer before, right? In the formula for midpoint, it would be my answer. Okay. So I'm going to take my midpoint formula. This is how I found the x coordinate for the midpoint. So I'm going to take this right here and use it to find one of the endpoints. Okay. And I'm going to do the same thing for y. Sorry, y'all. Okay. So here we go. This is how you find the coordinate, the x coordinate for the midpoint. You're going to take this part. You're going to substitute the information that you know. So look at this. This is one endpoint. You see how I labeled this x1, y1. This is x2, y2, and the answer is in the middle. So I'm going to use just the information I know. I only have one endpoint, so I have an x1. So I'm going to substitute 3 in for x1. I don't have x2. x2 is missing. You see how x2 is missing? And what I have is the answer. The answer was the midpoint, which is -2. So that's why I put -2 here. Okay, so I substitute all the information I have. Now, in order to get rid of, get this by itself, I got to move this 2 on the bottom. So the opposite of dividing by 2 is to multiply both sides by 2. So that's what I did. When I multiply this side by 2, because I got to get rid of this, okay, that's on the bottom. When I multiply this by 2, on this side, I get -4. When I multiply this side by 2, this cancels out, and I'm left with just this 3 plus the x to the x2, sorry. So to get x2 by itself, so I can figure out what x2 is, what that endpoint is, I'm going to subtract 3 on both sides. So that gives me -7 for my x value for my endpoint. So now I'm going to find my y value for my endpoint. I have one of my endpoints, so I plug in 5 for y1. That's what I got right here. Y2 is what's missing. The answer or the midpoint for y is 7, so I put 7 here. To get rid of this 2 that's on the bottom, I multiply both sides by 2. That's why I have this. So this cancels out here, and I'm left with just the 5 plus x2 on the top. Here, when I multiply 2 times the 7, I get 14. So now I'm going to subtract 5 on both sides, and this gives me 9. So my y value for my endpoint is 9. So basically what I did was just work backwards. You need to take a picture of that and go through it. If you have questions, just let me know. So that's primarily what you need to know for the geometry part. Look at this. Don't forget to simplify how to simplify a radical, what a square root is. Don't forget that. Do not forget, if you want to take a picture of this, go back and look at your notes on how to simplify or reduce a radicand. Okay, so just don't forget how to do that. Draw your factor tree. Okay, you see how I wrote all of the circled numbers under the radical sign? Then I look for pairs. I take out one number for each pair, and I leave the other numbers under the radical. Whatever I take out, I multiply together. Whatever I leave under the radical, I multiply those things together. So just make sure, look, I have a pair of 2s and I have a pair of 3s. I take out one for each pair. Okay, whatever I take out, I multiply together. Whatever's left under the radical, I multiply together. And that's my answer reduced, okay? So please make sure that you go over those things, all right? Okay, guys, please don't forget to read and study over your notes. All right, have a good day.